HVAC 360, episode number 26, Chartered Institution of Building Services Engineering. Hey, welcome back, everybody. Friendly neighborhood host, Matt Nelson, for another episode of HVAC 360. We have a really great episode for you today. This is actually another first for me. We have a transatlantic Skype call, so actually it turned out very well. I hope you enjoy the fidelity of it all. You know what? I'm not going to say too much here, but I will say that this is a conversation I had with Andy Ford, who is the current president of the Chartered Institution of Building Services Engineering, or CIBSE, as it would be called anachronistically. So we had a great conversation talking about a little bit about engineering in the UK. And then what they're doing there, and talk about CIBSE, of course. So I hope you enjoy the interview, and let's cut to the tape. This week we're talking with Andy Ford, who is the current president of the Chartered Institution of Building Sciences Engineers. Good morning, Andy.
Good morning. Good morning.
So tell me a little bit about your background.
I'm an engineer. I left school and went to university to study mechanical engineering when I was 18. Bath University, that's in the southwest of England. Then I came across building services as I left, really, and I went to join a company that actually structured itself as a democratic company, which is what appealed to me as a consulting engineer. And then I went there for some 8 years or so. And then I started my own business. And that's where I've been until 2009 when I sold it to my current company here, Mott MacDonald. So that's my basic background.
So what does Mott MacDonald do? What does your day job entail?
My day job is I'm a technical director in Mott MacDonald, and I run an element of it which is called Fulcrum, which is actually the name of my company that came through, which specialises in low energy design. Has done since sort of about '84 when we started. We've been designing low-energy buildings, and more recently became much more involved in looking at the wider scale of how buildings fit into the whole built environment and how you reduce the carbon issues on a larger built environment. So that's one of the reasons we joined with Mott MacDonald, which is an international consultancy. It's global. It's 14,000 odd people. My company was 150 when we joined. So it deals with, it's a civil engineering, water engineering, education, buildings, building structures, building services, trains, planes, all sorts of things is what it does. And the reason we're joining is we actually see the future being to do with cities, I think, and the way that building services and plugs into civil engineering is quite key to how that actually all works.
So I guess at what point growing up did you know you wanted to become an engineer?
That's I think I always imagined that engineering was all about design. So I've always liked making things and taking things to pieces. It's sort of, everything from my bike in the kitchen and then the motorbike in the kitchen to trying to build boats and sailing boats, making things, everything from sandcastles when I was a kid and damming streams, which caused flooding downstream when I'm at junior school. I had to go and apologise at one point for flooding somebody's garden because I helped to dam a stream when I was at primary school. so that's from quite an early age, I think, really. So yeah.
That's a pretty successful civil engineering adventure there early on.
Yeah, no, I didn't know it would happen. It's amazing. Slightly embarrassing. There you go.
So at the university, I guess, what were some of the favorite subjects that you studied there?
um, well, it's interesting, really, because I think it's design is what I've always been fascinated with. So I enjoyed the bits of at Bath University. They had a complete design course, so you'd spend 2 afternoons a week on design as a topic, which is a sort of a ties again to all the disciplines in engineering, and that's what has always fascinated me. That plus the laboratories. Frankly, I think going into the labs and hands-on approaches, breaking bits of metal, seeing what happens when you blow things through holes, it's just that sort of stuff fascinates me.
Now was the universe? I mean, did you know, aside from engineering, that you specifically wanted to go into sort of the HVAC, the building kind of sciences kind of angle?
To be honest, I didn't even know it existed. I, like most people, when I was in a building, I never realised that was an engineered object. You're just not, and if you're not in the built environment industry, I don't think you realise how much engineering and how much design goes into buildings. Most people just walk through them, they experience them, but they don't really see them. I went. One of the nice things, I suppose, at university is that I shared flats with quite a few architects, and that was an interesting introduction to the whole process.
So were there classes specifically geared at all towards building engineering?
No, I did mechanical engineering, which is a general engineering. So I was actually sponsored through university by a diesel engine manufacturer. So, we did things called sandwich courses. I don't know whether you have them there, but I did a thing called a thin sandwich course. So you'd have 1 semester in university, then 1 semester in the industry. And I went through a factory that made engines from raw materials. So they had a foundry at one end and engines came out the other.
Wow.
So I went through each of the stages from the foundry through to the machine shops, engine test, and production engineering all the way through. So it was great from that point of view. But then I decided I definitely didn't want to be in a small town in the middle of Gloucestershire. I wanted to be more in the heart of things in London and more focused on design. There's not many opportunities to design in that sort of engineering. As a consultant, you get the opportunity to design thousands of things, but not as a manufacturer.
Right. You're kind of trying to make it better one step at a time.
Yeah, you can make steps, but there's few opportunities. Like wasn't a huge manufacturing area, so there was only about 4 or 5 people in the design section of the thing, and there wasn't any vacancies. So I moved on.
So
found by mistake building services. So, yeah.
So how did you stumble upon it then? I guess
Well, it was literally, I suppose, stumbling would be an accurate description. I mean, I was at the time just at the university, just finishing my degree, deciding I did want to move into something else that led me out of factories. I was a bit fed up with being in a factory at the time, so I was looking for things. So I was just looking through the magazines, and I just saw this advertisement for company called Max Fordham and Partners that was just really attractive. It was just looking for people who were interested in buildings, but they were building services engineers. So I actually had a phone interview, and I went to start working for them the next week.
Wow!
So that's where it began.
So now, are there any, I guess, schools in England that do train building services engineers?
Schools, when you mean what stage?
Universities or
University, yeah. There are. I mean, one of the most specific is London South Bank University, which was after the war finished that became the home for building services. Really, I think when they demobilised they offered people leaving the military opportunities to go into various different industries and train up, and that was what is now London South Bank was the original heating and ventilating college in London, and it's where quite a few people went into. Indeed, my mother-in-law was one of them. So, yeah.
So now, are there, as far as getting into the building services field, so to speak? I mean, are there different paths, or does everybody kind of follow the same kind of format that anybody that is designing now?
No, it's a really interesting moment right now. I mean, the actual field of building services and heating and ventilating has tended to be. People have come into it from outside. They've come in from, like myself, come in from being a mechanical engineer, and then finding yourself in something, and either doing a master's in building services and moving into the profession, or alternatively, people have sort of started on site as plumbers, fitters, and then progressed up through a sort of step ladder approach, doing HNDs and then degrees, and coming into it that way. Right now, there's been, it's a terrible state at the moment in the UK in terms of young people coming into the industry, or young people having any work at all, really. So there's been a big effort to try and introduce apprenticeships, which are a bit like I described in some ways the course I went through. So it's Mott MacDonald, for instance, has just been working to establish one for civil engineers, where it's a 2-day-a-week release course with a sort of educational provider, and then you actually train up to reach a degree level, but actually working during that period. And I think I benefited personally enormously from having practical involvement in industry mixed up with the intellectual challenges of being at a university. And I do think that is the way forward, and I think the step-ladder approach is really good. It needs to be, as CIBSE president, what I'm trying to do at the moment is encourage it to happen, so that so the opportunities to join are available from different times in your life and different levels of interest. Because you need quite a wide mix of talent these days to be a good building services engineer. It's not quite as narrow as it used to be, and certainly the focus is really on us in terms of carbon and reducing the need for resources to make buildings comfortable.
Now, CIBSE, the institute. I don't know if you use that acronym, the CIBSE.
This institution, we call it. It's called CIBSE generally, yeah. Because saying it the long way gets rather boring. Yeah.
I completely understand. Now they have the Young Engineers Network. Now, when did that start?
Now I think that started. Let me see. I think that started about in the late 90s in Scotland. I think it started. There was a young group in Scotland in '92. And then Hong Kong came along in 2000, and then it's really started to accelerate probably since 2006. We started a London one, and now they're really, really going. Now we've got over 1,000 members in the various yen groups, and it's accelerating, which is great. It's really good news, really. Yeah.
So what are some of the benefits that specifically those young engineers get from that?
Well, what CIBSE has just done this year when you join the institution is that like previously you used to join, and then if you wanted access to the knowledge, which sort of the guides and all the backup information of technical memorandum and knowledge series, all this sort of information, which is sort of the distilled knowledge of all the engineers within the institution. You would then have to buy the specific ones you wanted. One of the things we've done as of 2012, is to open that up to anybody who actually joins. So if you want to join as a member of CIBSE, that includes the student membership, you can then get online access to all that knowledge. So part of, as long as you remain a member, you can get access to all of it. So we're shifting our approach to doing research and knowledge management to meaning that if you're a member, you should be able to get all that knowledge, and then you need to contribute your efforts into developing it. So it's a two-stage plan.
Excellent.
Yeah.
Wow.
Yeah.
So I guess, focusing a little bit on engineering in the UK, you kind of denote a little bit about the demographic with the younger engineers not being so prevalent. I mean, is that sort of, they're attracted to other fields of interest, or, what do you...
Well, I mean, yeah. I mean, when I say that a lot of engineers in the building services have come from the other side. So if you just take electrical engineering, for instance, one of the top places you might do that would be Imperial College. And what was happening was a lot of those engineers were actually going into the financial industry because there's hugely better returns coming out there. So, and that has slightly slowed down. And I'm trying to encourage people to come back this way, but it is a worry. There is a bulge of older engineers going through, around my age. I'm 57 now, but that sort of area, there's a hill of engineering, and we'll all start to leave, and there's a bit of a dip behind us. So we do need to draw people in from a wider cross section now. In particular, we're only in CIBSE. I think we're still taking a very, very small percentage of female engineers coming into the profession, so we really need to push hard to widen that up.
So, what is, when you kind of say, hey, I want to be a professional engineer. I mean, I guess, is that something that, once you get into the industry, it's a natural progression, or is it, exclusive to people who've actually gone to university? What's the process to become?
No, it's absolutely not exclusive to being at university. Well, there's various levels. You can certainly, to join CIBSE, you do not have to be a degree level engineer. You don't. You can just join, and then that gives you the structure to progress upwards. So we go I-Eng, and eventually it's C-Eng. C-Eng is chartered engineer, which is sort of equivalent to professional engineering in the States. It's a globally recognized badge. Chartered engineers will get you all over the place. You have to follow a structured training course after university, or there are structured training courses to get you to the point you want to be, and you can do this through an interview process and proving you have the necessary competencies. Chartered engineer isn't just building; it's all the engineering institutes actually will deliver the same thing. So they all are pushing for the same basic competencies, which is just demonstrating you know what you're doing. It takes about, if you leave university, you usually wouldn't manage to reach chartered into status for about 5 years afterwards. So it takes you about that long to go through and achieve the competencies. But as I say, you can do that from whichever level necessary. Now, you might end up having the best placed. The best thing to do might end up to be to take some time out and go to a course to do some of it all in one intense point. But yeah, you can get in at different levels.
So, and I guess just to make sure I completely understand, could you be in the trades and then progress up to become a chartered engineer? Definitely. You can do that, and I mean, I think it's really interesting there. I mean, it's great to be a chartered engineer if you want to be one, but none of this works unless we have a really, really strong supply chain, and that requires engineering skills and engineering knowledge
all the way down. I mean, wherever you are in that supply chain, you're adding something really serious to the ability to deliver, because it's about making things and delivering things that work. So you need people who are skilled at every single level. So absolutely, you can come in. You may have to take a master's course. If you came in at one level, you might find you need to do some more academic effort in order to get to the next level. Depends on exactly what you had to start with. But there's definitely a step ladder which will get you through to being a chartered engineer. And that's, as I say, it's a globally recognized qualification then.
Now, how just from the standpoint of just being a colonist over here, what is the international aspect of being an engineer in England rather than just working nationally?
Well, it's probably one of the reasons that people going into engineering in the UK is that they actually, internationally, the British engineers have got a pretty good reputation, and it does enable us to travel around. And there's a lot of consultancies. Admittedly, a few of them are being bought up by the Americans at the moment, but that are worldwide. And you can travel around the world, absolutely, definitely, as an engineer. And that is, as I say, it's one of the reasons people come into it, is because it opens up the opportunity for travel quite widely.
So you'd say most of the firms that are based in the UK are more international firms then?
No, it depends where you look. I mean, we're part of the European Union, so some of the large manufacturers are here, and they use. It's useful because English is we happen to speak English quite naturally ourselves here, whereas most people from other European Union countries don't necessarily do so. So it's quite helpful for them to be able to have England sitting right next to them, and they use that as a part of an international way of getting engineering around the world. The consultancies, there's a sort of very large consultancies, and then there's a very long tail in this country in particular of small consultancies, so very small ones, 4 or 5 people scale companies. Indeed, many of the construction companies are very, very small scale, although there's some enormous ones as well. So it's an interesting mix. Part of the challenge, really, if you're trying to actually decarbonize our whole built environment, is that long tail. So,
so you'd say that long tail would be more national on the scale of what they do.
They tend to be working here nationally in the country, or even very locally. I mean, there are some very small ones that do work internationally, and I think those ones that are, I suppose the ones that are dealing with building physics and sustainability specifically, and maybe working closely with architects. They quite often go international because the architectural practices that are ambitious work internationally.
Now, is there a lot of kind of marriages between the engineers and the architects? I mean, is that something that's prevalent?
There's lots of what, sorry?
If you have firms that have both architectural and engineering in-house, or those things tend to be separate?
There are some firms that are sort of truly that have that. There's not very many that are sort of complete mixes of architecture and engineering. It's still the case that the teams tend to come together. So, for instance, my company Fulcrum, when we worked with lots and lots of architects, quite many times over. So you could look at it and you'd see the sort of our clients. You see a chain of clients, but you'd also see repeat work with lots and lots of architects. So that we tended to work regularly with them, and indeed with other structural engineers, so that the teams would quite commonly come together. But there aren't that many companies that are both architecture and engineering in one place. It's I mean, I've noticed, for instance, that Foster's have just taken on a small engineering group, and there's a few others that are doing that. Generally, they use it to interface with consulting engineers, and they work quite closely. I mean, we work terribly closely at the very, very early stages, sort of before there is a building, trying to think through what the building form should be. We work a lot at that stage, and we're becoming more typical now.
Now, what about, I guess I have to ask about litigation. Obviously, that's something that, is really, in the U.S. tends to be a little bit more prevalent. How do you see litigation in the U.K.?
When there's a recession, it gets worse, for sure. That's, bothly because people are looking for ways of getting their money, and also during these times, you're competing hard on price, and the resource is quite limited. So you've got a narrow amount of work to do, and if you don't do it well, it can all go terribly wrong, terribly easily. So it's really important we have a good systems approach to checking how things are done. But there is, I would say, it's got better since I was sort of a young engineer. There's more collaborative working, but it's still quite an aggressive industry. It's not a sort of uniformly comfortable place to be. There's quite a bit of aggression in terms of. Aggression is not necessarily the right word. I mean, commercial aggression, if you like. I'm not quite sure how you say that, but is there litigation? Definitely there's litigation. Will it get worse? I really hope not. I think it's important that we manage to avoid that, and we've got a lot to do in terms of being innovative and changing our future buildings. And if we want to, hit our carbon targets, we've set legally binding carbon targets in this country, and that means we've got to really push hard to do new things. So we've got to cope with litigation.
So
better ways of dealing with it by discussing exactly who's to blame during the contract, agreeing things before they turn into litigation is important.
Now, I guess, is that something, because obviously when I think of, hitting carbon targets and, all that kind of relates back to the, energy and the energy usage.
Yeah.
Is this like, I say measurement and verification of your design? Is that something that's, been around, or is that something that's, that's being, I guess forced, onto the stage just by, because they have these carbon targets that they're trying to require?
Well, we have we're into looking at the fourth carbon budget at the moment. That's what's sort of going on, and we have to hit targets as the UK, legally binding targets of reducing our carbon from 1990 levels. Now, they have looked at the various industries, and they've decided construction is one of those low-hanging fruits, I think they call it. It's pretty hard low-hanging fruit. But so there's a lot of, the building regulations are changing every 3 years here, and they are pushing hard on the carbon targets, very, very hard. And the latest ones are really hard to meet, and they aren't the final ones. So it's pushing the involvement of engineers right back into the early stages of design, because you cannot meet these sorts of targets without being involved at the very, very early stages. So I would say, the carbon targets are really a major thing in the UK. They're they're challenging, and they're getting more challenging, and they are embedded in regulations. So all engineers have to learn how to do it. We do tend to be the bad boys, and at that stage, and it's sort of we're the only ones who sort of know what we're talking about in the design team. But you've got to get the appointments to catch up with that, so that because you might know what you're talking about, but you might not be paid to know what you're talking about.
So by hitting the carbon targets, I guess, does it trickle down to the, like a building level, like a building contract saying you're going to design this building to meet, X standards? Yeah, I guess essentially that's what you're saying, that there are codes in place.
I'm saying at the moment, until this year, it was a predictive level. So and now they move to they will check that your building does deliver what it says it's going to do. So you can see what's happening, and you do wonder who's going to take responsibility for all this in the longer term. But it does bring together facilities management and design, because that is the next logical step, is linking energy supply, facilities management and design of buildings all together. I mean, because you're being asked, we have to predict the performance of our buildings almost before there is any design at all. And then we have to make sure that what we said at the beginning turns out in the end to be the truth, which is quite a hard task. If you know through the stages you've got to go through and the breaks in the process you've got to get past, and the fact that you don't necessarily have full control over all this, you eventually have no control over the way that people operate your building at the moment. So it's getting tricky, and it involves sorting out the contractual arrangements so that such things can be delivered.
So who's in charge of verifying, the end result?
At the moment, it falls down to At the moment, it's within the building regulation. So the building regulation checker is the person. So it's in building regs, and that's where it lies.
Okay. All right. So let's change focus a little bit. Let's talk about the institution, Chartered Institution of Building Services Engineers.
Yeah.
What is your elevator pitch? What is what is CIBSE? What are they all about?
Right. Okay. So I should know. So what is CIBSE? CIBSE is it's the institution that brings together all those people who are interested in the performance of buildings. We have it has a tagline for the greater comfort of mankind. So it's about changing buildings from shells to being things you want to be in. I think that's it. And that's what building services is. That's what CIBSE does. CIBSE provides a place for all those interested to go and to find out how to do it and to contribute their knowledge to it.
So what kind of the origins of CIBSE? When did it come about? I mean, obviously it's probably a fairly old organization.
Oh God! It's changed its name. It used to be known as the IHVE, Institute of Heating and Ventilating Engineers, when I was a young engineer, and then it became Chartered Institute of Building Services, and then it became Chartered Institute of Building Services Engineering, and that is this sort of line. And I actually can't remember when it was first came around. I'm not sure of its actual history. I'd have to get that checked.
All right.
It's a bit embarrassing, but there you go. It's been around for a while, shall we say?
Yes. We'll Google it.
Not hundreds of years. It's not one of these things. It's not one of these old institutions in the UK. It's sort of half a century, that sort of level.
Oh, okay. Well, I'm sure we can Google the information. If I find it, I'll take a look for it. If I find it, I'll put it on the show notes, just in case people are dying to know. Not like it's going to show up in Trivial Pursuit or any game shows anytime soon. But I thought I'd ask.
Maybe I'll do that now.
Now, the institution, it's I guess unlike what you've kind of alluded to, it's more than just HVAC, correct?
Yes, it is.
So
it's lighting and facades, public health, all of those things in one place.
So why? I guess do you have any idea? The rationale. Is it just trying to be all encompassing in the engineering? Does it did it take the place or combine a couple of different societies that existed?
Yeah. I mean, essentially, without thinking about all those things together, you can't deliver a building. So it combines a number of societies. I mean, it has several societies within it. As I say, it's got the Society of Light and Lighting, and it's got the Institute of Society of Public Health Engineers, and it's got it has various different groups within it, and I suppose it was an umbrella organisation already, but it's becoming more and more so as we go forward.
So I guess when we're talking about internationally, what's the reach of CIBSE?
We're in something over 90 countries. I think we've got members scattered all around the world. They are. We have sort of large groupings in Hong Kong, Australia, New Zealand, Ireland, and then we have smaller groupings with sort of country representatives in the sort of the Middle East and in I don't know whether we've got that many in South America, to be honest, but beyond that we have small groups in. We've got country representatives in quite a lot of the countries. China has got a country representative. I've been busy visiting them. A wide range, and then you go down, and you'll find there's a few engineers in most countries you come across actually, and those engineers actually travel around quite a lot. So it's not necessarily a sort of a fixed place. When I say we've got engineers in a country, we do, and some of them are permanently there, but quite often they're actually travelling around, so they'll be in different countries as well.
So what's the process of becoming the CIBSE president?
Interesting. It's not something I expected to happen to me. I mean, I can really only speak about the process that I came in. You become involved in the institution, as in you want to add something to it. So I became involved in contributing to some of the guides and contributing some of the guidance, and then I ended up on something called PROD, which is Publications and Research Output Delivery, a committee. I became involved in a committee. Some people will come in. More commonly, people will become involved in their local committee, and then they will go from the local to the national. What happened to me is I was involved in the research side of it, and eventually you end up onto the council, which is a sort of a larger body of about, how big is that? Probably sort of 50 people from all our various areas from around the world and around the country, and the different groupings who advise the board, and then from the board you're elected upwards to from the council you're elected up to the board, and then from there you can become a vice president. And there's 3 vice presidents, so you don't have to be a president if you've been a vice president, but in order to become president, you have to have gone through being a vice president. So it's an election process to get to that one. So I was elected member of the council, I was an elected member of the board, and then became the vice president, and then became president, which again is elected.
So do you have a presidential theme that you have?
Yeah, I do. As one does. Yeah, I mean, my theme is actually it's about respect. Because what I'm trying to work out is how we actually solve a very, very large problem, and how, as building engineers, at the heart of this, we need to respect people down our supply chain, and the people at the academic level, and to respect the various different contributions brought to design by architects, by quantity surveyors, by structural engineers, and surveyors generally, so that we have a sort of T-shaped industry, and it's really important that we have a good understanding of what each brings to the equation, and how to make the best of it, and how to speak to each other in respectful ways, not to just think of architects as people who do fancy drawings, to understand that they are trying to pull together an awful lot of very complicated ideas and turn it into a product, and that we have a place in that, and we should make positive contributions to how that happens. So it's about respect, and then I've got another one which is about driving to get young people to come into this industry, because it's a great industry to be in, and it's creative. It enables you to get out and about. It's project-based, so you're not working always on the same thing, and it enables you to travel the world. And finally, we just got an absolute need to drive a continuous cycle of improvement to deliver on a sustainable future.
Excellent.
That's about it.
Yeah, you pretty much hit a lot of hot topics there. So I guess anything that surprised you. I always like to ask you became president, and you had kind of an inkling of what it would all entail, but really until you get that appointment and start going through the different obligations or activities, was there anything that they kind of said, I don't think they told me about this one?
No, yeah. There's quite a lot like that, actually. It's a really busy time. I suppose that's the bit you don't realise. I mean, I don't know whether this is just particular to the timing when there is so much pulling together going on, but I didn't realise how much time I was going to be spending trying to link people up, to pull them together. And I also didn't realise that as soon as you become president, everybody therefore assumes you know absolutely everything about CIBSE, which is interesting because you don't. And you're there for a year, and you've got a heck of a lot to get done. Yeah, it's been an absolute pleasure, to be honest. It's really good. I've really been delighted by the enthusiasm shown by all the people I meet and for our industry, and it's great. Yeah, but there's been a few surprises along the way. Like I didn't know I had to go to a white tie dinner. I didn't know what is a white tie dinner. Those sorts of things. Yeah.
I'm not sure I even know what a white tie dinner is now.
Oh, well, I'll tell you next week. I've got to go to one. You have to dress up in white tie and tails, I think.
Just be like the word.
Very British sort of thing. So.
I don't know. I envision that as a accident waiting to happen. I just
yeah, could be a bit splashing. Yeah.
So I guess what is obviously you've been around the industry a long time, and you have this kind of trying to get young engineers involved. What are some of the things that you try to communicate to younger engineers when they just to help them avoid some of the difficulties that you may have seen?
Well, I mean, I think the interesting thing, really fascinating change that's happened is that actually the young engineers are the only people who've ever been taught about sustainability. So it's only been around as a sort of thing to study for 10 years. And then you've got how things happen and how to make things happen, which is embedded in the older generation. So we have a really interesting combination at the moment where this is why I think the respect issue is very important, and it's a two-way respect. It's necessary for the young engineers not to think they can just whiz through and just say things and they'll happen. They have to understand that if they want them to happen, they're going to have to explain to an older engineer, and then it will happen. Because the processes are quite key to our industry. So understanding the processes is quite important. Understanding that it's fine to say what you think. The aim of the exercise is to talk sense. It's not to just deliver what somebody is asking you about. It's about thinking creatively and contributing your ideas, as long as you know what you're talking about. So I would say at the moment there's a big opportunity for young engineers to say what they know about, and that is about sustainability, certainly here. And if they want to get on, they should explain it and explain how it can happen. And that's a debate between generations, so that we can all then turn it into something that we actually want to happen, because we want a better society in the future that's more fun to be living in. Get on with it, I would say. Be ambitious.
So through all your career, what have been some of the fun projects that you've worked on?
The fun projects.
or a favorite project.
The trouble is with projects is I find that they're fantastic fun, and then they go through this really hard bit where you actually build it, and it gets a bit stressful. They're nice to look back on later on. So I've done some really interesting projects in my life. I've been incredibly lucky, and that's even from the very early stages. I mean, I remember one of the first buildings that I ever did was in the sort of late 80s, was an extension to a house where the client wanted it to be completely glass. And when he said completely glass, we said, all right, what do you mean? Well, all of it. Okay. So it's structural glazing. It's the heating system was the glass. So you control the temperature of the glass. It's electrically coated glass, so you can control the temperature. So that was really just a challenge, a challenge and an interesting one. And then I persuaded the University of East Anglia that they should adopt a low energy approach, a life cycle approach to buildings. And we built in the early 90s several student residences, which are really elegant buildings, but were hitting sort of, they were pressure tested, so to 50 pascals to check their air leakage. They were highly insulated. They had heat recovery ventilation in them. Lots and lots of innovative things. They had siphonic drainage systems. Very exciting, really interesting things. And then probably there's two further ones, or three maybe. I did a thing called the University of East Anglia Elizabeth Fry building, which is where we removed the heating and cooling systems from the building and just did ventilation. And to control the temperatures of that ventilation, rather to control the temperature within the spaces, we ventilated the concrete slabs. so that they turn into a sort of radiant heating and cooling system. So we built on what we'd previously done by isolating the outside of the building with a lot of insulation and airtightness, and then controlling the temperature just with the structure. That was good. We then took on to, if you can, that involves storing heat from sort of day to night. And the fascinating thing with that is the building becomes amazingly insensitive to what's going on outside. And then you realise that there's other fluctuations, which are seasonal fluctuations. So that became a major challenge to see if we could hit. How can you design a building that will use the seasonal fluctuations? So use the excessive heat to warm you in winter and use the excessive cold to cool you in summer. And that involved reorientating the location of insulation layers. And there's that actually came from America. That was a Rocky Mountain guy, and Rocky Mountain Institute, I think it was. So we did one of those. That's passive interseasonal heat storage, and then we looked at active seasonal heat storage, which is probably where we are now, which is collecting the heat. And I built a building recently which uses a tarmac outside, a school tarmac playground, to warm the school by storing the heat underneath it and putting it back into the winter using heat pumps. And now we're doing that at large scale. So we're now using the aquifers to store the heat and cool and deliver them back into large groups of buildings. And that's where we've got to at the moment. That's where we are. I think it's about realizing that large-scale storage of heat at the temperatures you need is available, can be collected, and can be used in the building. And that's where we've got to at the moment. It's brilliant at the moment.
Sounds absolutely fascinating. Now, the storage that you're talking about. I mean, obviously, when you say storage, I think of like a geothermal heat exchange kind of.
Yeah,
kind
that's
of
all we're talking about. I mean, it's just that you've got geothermal heat pumps, and they just drag heat out of the ground, and it naturally goes back in. And it's just enhancing those processes. That's all we're talking about. And heat pumps are now becoming, ground source heat pumps are not new anymore. But 10, 15 years ago, they were new. And the way we were thinking about it was not concentrating on the heat pumps, but concentrating on what was going on underneath the ground and how to enhance that effect. So, I'm looking at de-icing roads using stored summer heat without any heat pump and things like that. So it's
okay.
Yeah.
All right, excellent. Now I guess we're pretty much wrapping things up. I don't know if there's anything that you wanna anything final that you want to say about CIBSE or not.
Well, I mean, I'm really pleased with at the moment is CIBSE's relationship with ASHRAE, which is really going from strength to strength. I see at the moment, and it's encouraging. We need to work together. I can see some excellent work that ASHRAE is doing, and I would love to see that relationship turn into something solid. Solid, and enable us to work together around the world more effectively. So I'm hopeful. I'll be at ASHRAE in Chicago, and I'm looking forward to it. And I hope we have some good discussions.
Excellent. Now I have to ask, one of my favorite shows, kind of off topic here, is Top Gear.
Really?
Yeah.
Okay. Why is it your favorite show?
No, you know what? I find it. I guess Monty Python's been a big. I love the Monty Python. The British humor, so to speak. But Top Gear is it's one of these. There's something about it. It's entertaining, and it's some visceral sort of
You know,
I think it's brilliant. I have to say, this is probably getting me lots of trouble with lots of green people, but actually, I don't particularly like the fact they're concentrating on supercars and fast cars, but the excitement in the engineering of it all is what I find fascinating. You know, this
absolutely.
you know, it's and I've seen. Have you seen all the who are the three people? There's Hammond.
Yeah, Hammond, Richard Hammond, Jeremy,
and the other guy, the John, the other end of the scale.
Yeah,
the one who's sort of slightly.
who they call Captain Slow, I believe.
Yeah, him. He has done some wonderful challenges with universities about, you know, he's built a bridge out of Meccano.
Oh yeah, he did.
And he's done this sort of like taking a slot car around the original track, which is now the original big bowl that is a racetrack, which now half of it is actually housing estates and God knows what else. And he's got the whole communities actually acting together. And that's all about excitement and enthusiasm for engineering, which I think is great. I hate his green views, but the excitement is good. Yes. Yeah.
Excellent. Well, yeah, it's funny. I stumbled upon it a couple of years ago, and it's one of these fascinating things that I watched 3 episodes yesterday. I was, blowing off some time, and I just to prep for this a little bit, and I'm like, okay, I'll watch a couple extra episodes.
Well, my daughter's decided to be an engineer, and I wouldn't be surprised if that's not part of it, because she's been an addict to it. Yeah.
All right, excellent. And you don't offhand know the identity of the Stig, do you?
No, I don't.
Okay.
Afraid not.
No.
Can't help you there. No.
Okay, well, and I will post a note in the show notes just in case people are totally lost of what we're talking about. But I really appreciate you having being on the show, Andy. If somebody wanted to get a hold of you, what's the best way to get a hold of you?
Probably email me on andy.ford@mottmac, that's mottmac.com.
All right. And I will put that in the show notes so people won't have to scurry and write it down right now. But again, I appreciate you being on the show, and I guess continued luck on your presidency, and hope everything goes as you had planned.
Well, thanks very much. It's been a pleasure to speak.
All right, and we're back. Well, I hope everybody enjoyed the interview. I would like to once again thank Andy Ford for taking time out of his busy schedule to be able to talk with me. It was a great time. Kind of in talking with Andy, it really is. You really have to change. There has to be this paradigm shift between the old way we engineer things and the new way we engineer things. And now that everybody's becoming so energy focused and energy conscious, I think kind of after we had the interview, I had a chance to chat a little bit with Andy. And one thing that struck me that he said was that when I would say, when engineers take a look at making a system more energy efficient, they tend to make it more complicated. And he said, it's not about making more complicated, because that only makes things, inevitably fail. But it's about taking things out. And I think you really have to, if you're going to make something simple. Obviously the most efficient kilowatt is the one that you don't use. The most efficient piece of equipment is the one that's not in the system. It's something that we have to learn to simplify systems, to use the building more effectively at acting as its own system. And not necessarily just adding more equipment, more complicated equipment, more complicated sequences. really that's kind of my 2 cents in the whole conversation. But really great to hear Andy. If you want, again, there's a few things that I'm going to add to the show notes for you for contacting. If you have any suggestions, you can always shoot me an email, matt@buildingx.co, or you can follow me, just connect with me on LinkedIn, or if you want to follow me on Twitter, if that's something that you're into, I'm at buildingx. So if you like this episode or want to hear different topics, let me know. If you liked what you heard, why don't you share it with a friend? I'd appreciate that. And if you want to know, obviously we have a newsletter that goes out monthly. It's brief, it's not too bad, and it's just kind of a recap of where we've been. If you don't necessarily connect with us on a regular basis, it's a great way to touch base. So, and I kind of throw a couple behind the scenes things in there from week to week and kind of give you a little heads up of what's coming. So if you do that, go to buildingx.co, and it's right there on the upper right. Sign up, and it's fairly painless. All right, well, I guess that's it for this week. I appreciate everybody listening. It's really great to be able to do this, and I think that hopefully you found some value in it. So until next time, remember, know what you build, and share what you know.